things get a little more interesting when we talk about trying to multiply two vectors together. So let's think about the vector A and the vector B. What does it mean to multiply two vectors? Well, it turns out there are actually a couple of different operations that correspond to multiplication for two vectors. And in this clip, we're going to talk about one of them, which is called the dot product, also known as the scalar product. Notationally, it's a fairly easy one to remember why it's called the dot product, because when you write it, you write A dot B. And as far as what it actually produces, it's the other name helps you remember that. It produces a scalar. So A dot B yields a scalar value. It just produces a number. And of course, it's a number that has the units of whatever the units of A are times whatever the units of B are. So if this were meters and this were meters, A dot B would give you units of meters squared. We can think about what dot product means both graphically and in terms of components. So let's think about it in the sort of coordinate-free graphical way first. So here's the vector A, and here's the vector B. If I want to know what the dot product of A and B is, what I do is I first draw them so that their tails are together. And then I look at what the angle is between the two. And the dot product, A dot B, is the magnitude of A times the magnitude of B times the cosine of that angle that lies between them. Now let's think about some cases of that. What happens if theta is 0? Well, if theta is 0, cosine theta is 1, so that gives us magnitude of A times magnitude of B. And if you think about it, that's actually the largest possible value for this, because the cosine theta is always going to be less than or equal to 1. So it's simply magnitude A times magnitude of B. It's big, right? When theta is pi over 2, it's cosine of pi over 2, which is 0, so I get 0. And when theta is pi, right, in other words, when it looks like this, I get negative magnitude of A times magnitude of B. So if you think about that qualitatively, what the dot product actually tells me is how parallel these two vectors are. So that's one question you could think about the dot product answering for you. Another question that it asks is how much does A point in the direction of B? Okay. Now, component-wise, you might look at this cosine and think, oh god, that's going to be a huge pain to deal with. But it actually turns out to be fairly simple to deal with the dot product in components. So let's say that A is 3 times I hat plus 4 times j hat, and B is 7 times I hat minus 2 times j hat. The way that you figure out the dot product is simply by multiplying each individual component and then adding up the results. So we take the x component, or the I hat component of A, times the I hat component of B. We add to that the j hat component of A times the j hat component of B. So A dot B in this case will be 3 times 7, right? X component times x component, plus 4 times negative 2, y component times y component, and so I get 21 minus 8, which is going to be 13.